we have discussed about t-test, f-test, ANOVA analysis, the theoretical part, probability distribution. Today what I'm going to discuss is I'm going to discuss about different type of test. Means for interview also it's very important, and for analysis also it's very important, because you might have so many tests. So which one should you use at what situation? So that knowledge you should have. So the first one, what you need to know, that what type of variables are there. This is the first thing you should know, and on the basis of that you have to take the decision that which test you are going to apply. So suppose variable 1 and variable 2. Okay, so many variables you might have. So let's start from that assumption that we are having two variables. Okay. So variable 1 is categorical. Variable 2 is also categorical. So what does it mean, categorical? It means, let's say, it's we already discussed on first day, like what is categorical data. Like this type of variable can be divided into some finite groups, just like your gender, number of cities, they are finite. Okay, in nature we can count it. How many companies are there which are producing laptops or mobile phones? So we can count the number, right? So if suppose I want to know whether there is any relationship between region wise and gender wise, is there any relationship or not? Means region wise, is there any disparity in the proportion of male and female? I want to check it. So there are what I need to find out the relationship between region and the gender, isn't it? So that's why the region is also categorical data and the gender is also categorical one. So what is we are going to apply here to know whether they are related or not? Chi-square test. So chi-square test is mainly used when we are having two categorical data and we want to know whether they are related with each other or not. Okay. Now next is continuous data and continuous data. Means two variables. Again we are having two variables, but they are continuous in nature. Let's say price and the demand for a product. So I want to know whether they are related or not. So that time what we use the concept of correlation coefficient, right? We talked about correlation. So correlation coefficient, it ranges from -1 to +1, right? And if it is close to -1 or close to +1, so their degree of association is strong. So they are strongly related. Otherwise, if it is close to 0, then they don't have any relationship or their relationship is very weak. So in this way, the correlation coefficient helps us to understand if two variables are continuous in nature, whether they are related with each other or not. Next is paired t-test. When you are having two continuous data, then we also can use paired t-test. So let me give you one example. Let's say I want to know whether there is any increase in the average sales after the advertisement. Okay. So two data I want to know. The sales of my product before advertisement and the sales of my product, average sales obviously, average sales of my product before the advertisement and after the advertisement. Is there any change or not, or they are still equal? So I want to compare between these two groups. But remember here the variable is same. Means the average sales is the variable, but the situation has been changed. Okay, the average sale before advertisement and after advertisement. So in this way we just separated it into two groups, but the variable is same. Another example is there. Suppose I'm predicting my average sale would be 500 units, let's say. But actually I observe it is 300 units. So I'm comparing between my predicted and my actual or observed one. So this is also the example of paired t-test, or where we can use paired t-test, because here also the average cell we are considering only one variable, single variable or same variable we are using. Only the situation has been changed. So there we use paired t-test. Categorical data and continuous data. Again, we are having two variables, but now one variable is categorical in nature and one variable is continuous. And only two categories. What does it mean? Only two categories means we are considering only two groups. Okay, so categories means group. So don't think it is another categorical data. One categorical data you are having, one continuous data you are having, and two groups you are having. Let's say I want to know whether Kolkata's population's average income is same as Bangalore's population's average income. Okay, so my income or average income is the continuous one, and if I say that state city wise, Kolkata and Bangalore, two cities I have considered, means two groups I have considered, right? And cities are what? Categorical in nature. So Kolkata's average income and Bangalore's average income, whether they are same or not, I want to test it. So that time I'm using unpaired t-test. Okay, so next is your categorical data and continuous data. More than two categories if you are having. If you are having more than two groups. Let's say you want to compare between three cities or four cities. Kolkata, Bangalore, Delhi. Okay, and you want to know whether their average income is same or not. So that is what? One-way ANOVA test. And categorical data and continuous. The last one. Now suppose you want to know city-wise, region-wise, average income, they are same or not. That is two-way ANOVA and interaction. So that is what your different type of test. Now here you are having the null hypothesis of test as well, because you know. Okay. So the null hypothesis is when you are using chi-square test, because we talked about different type of tests and when to apply what. But the thing is that we should know what is the null hypothesis, because if we don't know the null hypothesis, so that's why and on the basis of that we can take the decision. Okay, so chi-square test is, suppose H naught is null hypothesis. What is the null hypothesis? No association between the variables. So if you find that H naught is true, means null hypothesis is true, that means region-wise gender, they are not related with each other. Okay, in Pearson's correlation coefficient, what is null hypothesis you are having? There is no correlation between two variables, right? So if you find your null hypothesis as true, that means the variables for which you are testing it, you will get to know that they are not related with each other. If you find the null hypothesis is true, if you find that P is low, that means your null hypothesis is false. So that time you can understand that they are related with each other. Okay, one sample t-test is what? Suppose if I just want to know, I have assumed that Kolkata's population's average income is 30K per month. So I want to test it. So that time the test is called one sample t-test. Unpaired t-test we already discussed when we are comparing okay, between two groups, Kolkata's average income and average income in Delhi, whether they are same or not. Paired t-test means actual and predicted, or suppose the average sales before advertisement and after advertisement. Okay, ANOVA analysis also we did. Say one way ANOVA is ANOVA is average sales in different countries and regions. And what is interaction? See, country-wise in region 1, region 2, region 3, there is an interaction. So that part is called as interaction part of your ANOVA analysis. So this part is very important, that what type of test we use at what situation. So that is what our different statistical test is all about. Now next topic is okay, so next is our linear assumption. So we talked about different type of modeling, right? We talked about regression model, linear regression model. So in linear regression model, we have some assumptions which has to be satisfied. Okay, so in linear regression model, we are having mainly 4 assumptions which has to be satisfied. So one is homoscedasticity. The error terms, they are homoscedastic, or the residuals, they are homoscedastic. The residuals are homoscedastic. There is no autocorrelation between error terms. There is no multicollinearity, and the errors are normally distributed, or residuals are normally distributed. So what is that? What is homoscedasticity? Actually, it's just like the variance part. Okay. Homoscedastic means if the variance is constant. Okay. And if it is not the case, we are calling it heteroscedastic. So just look at these graphs and compare these graphs with this one. Let's say this one. Okay, this is an example of homoscedastic. You can't see that variance is increasing or decreasing. Okay, but if you compare this graph with this one, you can say that the variance is continuously increasing, right? The variation is increasing, right? So what is variance? It's the difference from the mean. So it is spread out. Now, biased and homoscedastic. See, biasness means when you are having any pattern. Unbiasedness means when you don't have any pattern. Here we are having a pattern, right? But you can see they are constant in nature, means the variation is not increasing. But here if you compare this graph with this one, you can see that it is biased in nature. It has a pattern, but the variance is continuously increasing, right? Next, this one. It is also a pattern. It is following up a pattern. Here also you can see it is also following up some pattern, but here you can see the variance is increasing. So these 3 are example of heteroscedastic, and these 3 are the example of homoscedastic. We always want to get homoscedastic. Okay, the variance should not be increasing or decreasing. It should be constant, right? So that's why you need to check it. Obviously, different type of tests are there. In R, in SAS, we use this to test. So there also, you will get one p-value. And I already told you that whenever you are doing any test, there is a null hypothesis. So we usually use in our BP test, Brush-Pagan test, or other tests are also available. In SAS, we don't use a BP test. Okay, some another test is there. Okay, so anyway, so there the null hypothesis is if we are following a Brush-Pagan test, BP test. So there we use the null hypothesis is it is homoscedastic in nature. So it's always better to get P value high, because if you are getting P value high, then your null hypothesis is true. That means your data set, your error terms are homoscedastic. So one assumption is satisfied. This is very important. Okay. Next is your autocorrelation. It's mainly appears when you are working with the time series data, but in linear regression model also we expect that the error terms are not correlated with each other. Let's say if you see that there is a hike in the sales after each 6 months in every year. So in every year you are having hike for 2 times, right? So, and if you just observe from last 5 years or 10 years, you see the same pattern. That means there is something which are related with each other. That's why that leads to the replication of certain event. So we are calling it autocorrelation. If the error terms are related with each other, then we find this type of thing. And in time series, we are calling it seasonality. Okay. So this is also, we can't allow to be in our model. So the error term should not be autocorrelated. It is in detail. Go through it, you can understand what is it. Okay, and these things you will get when you will do time series analysis and all. You can just plot this graph and you can understand that, okay, this is the pattern. We use ACA, PACA, different type of model to understand it, whether there is a seasonality or not. And then in SATs, we can find out the time interval as well, that what is the time interval where there is a replication, and using that we can just get rid of the problem of seasonality. Anyway, so that means autocorrelation means if error terms are related with each other or not. So here also the null hypothesis is there is no autocorrelation. So it's always better to have a higher p-value. Okay. Next is normal distribution. Obviously, we talked about what is normality. Before testing normality for your model, we already had the data and we can use the descriptive statistics to understand whether it's the assumption in the model is going to be satisfied or not. We can use different type of concept like skewness, kurtosis. We can plot histogram, okay, to see the pattern of the data set. And then at last in model, the very famous test we can do, obviously other tests are there. So it depends on the analyst what test they would like to implement. Anderson-Darling test is a very famous test to know whether your models error terms they are normally distributed or not. So it should be normally distributed. It's very, very, very important assumption, because you see when you are developing a model, linear regression model, I'm not talking about any other model. The linear regression model is based on the normal distribution mainly. So autocorrelation is very important, but normal distribution has to be satisfied, because if it is not normally distributed, the whole procedure what we have followed up till now would get violated. So it's very, very, very important to get satisfied. I mean, this normal distribution test should get satisfied. Okay. Okay, and then the very important one, multicollinearity. What is multicollinearity? It's suppose you are having so many variables, independent variables in your model, and you have found the significant variables as well. Means the independent variables now you're having in your model, they all have a significant impact on your dependent variable. But the problem is that they are interrelated with each other. What does it mean? Let's say my dependent variable is demand, okay, and two independent variables I'm having. One is price of the product and the income of the consumer. So now if you say that price and income, if they are related with each other and you want to know if there is any change in the price, your demand would get changed by how much? You want to know that. But price and income, they are related with each other. So when price is getting changed, income is also getting changed, and they both have some impact on demand. So demand would get changed. Okay. Now, is it possible to know how much effect is coming from the change in price? So separately, you can't know it because they are related with each other. When income is getting changed, price is also suppose getting changed. So how will you determine that how much the income is affecting your demand? It's not possible. So we might make a big mistake if there is a problem of multicollinearity. So it's very important to get rid of the problem of multicollinearity. So usually we use VIF, variance inflation factor, and it should not be more than 2. Okay. The best output is if it is from 1.5 to 1.7. So when you will do R or SAS, you will get to know in detail about VIF, how to use this VIF concept. And let me tell you that it's not possible to reduce the problem of multicollinearity totally, because little bit interdependency might be there among these independent variables. But as much as it is possible, we will try to reduce this multicollinearity problem. Otherwise, the model we will develop, that would not be appropriate one. So these are the main 4 assumptions for linear regression model. If one of them is not satisfied, then we might say that the model we are developing, that can't be generalized. It means that the data set what I'm using to develop the model, it is only valid for that data set. For another data set, we can't develop, or we can't use the same model for another set of data because it is not generalized. But if all the assumptions are satisfied and we got a very good R square and adjusted R square, and that time we can validate our data set and we can say that our data set is generalized. Okay. We talked about linear regression. Another model is there, that is logistic regression. It's a very famous one. I would tell you that when we use this logistic regression, let's say if we talked about binomial distribution, right? So the examples of binomial distribution. So let's say the financial institution, they are going to predict, or they want to predict that whether the new customer, he is going to default or not. I mean, he is taking some loan from the bank. So the bank wants to predict that the customer is going to default in future or not. So he will default or not, or he will buy the cross sell product or not. So yes or no. So here we can see that 0 or 1. If it is yes, then 1. If it is not, then 0, in that way. So only 2 possibilities are there. Either he will accept it or he will reject it. So 0 and 1. So nothing in between these 2 values, right? So that means it is binomial distribution. Okay, so when the dependent variable we are having, which is following up the binomial distribution and which is discrete in nature, then we can't develop linear regression model. We use For the time being, you should know it. When you will start doing it in R and SAT, you can understand. Only the examples because I saw so many students are there who get confused that when to develop a linear regression model and when to use the logistic regression concept. Okay, so just remember that when your dependent variable is continuous in nature and it is normally distributed, obviously we are developing linear regression model. When you are having dependent variable which is binomial in nature, 0 or 1, then we are developing logistic regression model. And the last about time series. Series is what? Time series data when the value of a particular variable is getting changed over a period of time. Then we are calling it time series data. Now what are the components of time series? There are four main components. Okay. So one is secular trend. What does it mean? Let's say smooth, regular and long-term movement. Okay. Let's say population growth, decrease in demand for a particular product or increase in demand. So which is smooth in nature. Population growth is the best example. And it's a long-term movement, obviously. So we are calling it secular trend. Seasonal variation, what is it? It's a periodic movement. Let's say, it depends on customs and habits, right? So the demand for umbrella increases when it is rainy season or in summer also, not in winter. Okay, in summer the demand for AC is getting increased. So this is what seasonal variation, and obviously it is here the time period is not more than 1 year. Next is your cyclical fluctuation. It is here, I mean this type of fluctuation can be observed. Obviously it is periodic in nature, but here the period is more than 1 year. We talked about actually whenever we're talking about economic activities and all those things, we talked about 5 phases. Okay, when there is a prosperity. Okay, so I mean there is a growth, investment rate is increasing, employment rate is increasing, so good time we are enjoying. Boom phase means this is the best situation for an economy. Then recession or decline, so investment rate is decreasing, unemployment rate is increasing, so bad things are happening and good things are not happening. Depression is the worst situation. Okay, when we are having maximum unemployment rate, lowest savings rate, lowest investment rate, highest crime rate, like that. Recovery, obviously from the worst situation we need to recover, we need to again just come back to our original situation, so that is what recovery. So obviously you can understand, so these 5 phases can't be achieved within just 1 year. So here it is a long term, more than 1 year. And the movement, it is a variation which are caused by the factors of an erratic in nature which you can't predict. Okay, which you can't predict, just like your floods, strike and lockout, war. Okay, what you can't predict. So, but it happens, natural calamity, it happens, and that's why if there is any variation in the production, in the sales, whatever is it for which I'm forecasting anything, so that is what random movement or irregular movement. So a very famous concept or measurement That is a moving average concept we use in the forecasting. Moving average is one, another one is autoregressive, another one is moving average autoregressive. Okay, means ARIMA, autoregressive moving average and integrated. Okay, so these are the 4 types of measurements what we can use for time series forecasting. When you will do those things, you will get to familiar with those concepts, okay, in more detail. For the time being, you should know only the concepts of what is time series data and what are the types of time series data. And then when you will start using some statistical software, you get to understand, okay, this is how we can just forecast the value, because time series data we are using to forecast. I want to forecast the sales for next 6 months or next 10 months. Okay. So for this, we have some measurements, like I said, that autoregressive moving average, autoregressive moving average, autoregressive integrated moving average, these measurements. The best measurement is obviously ARIMA, okay, among these 4, because it always gives you the best result. And that's all about your time series analysis. Okay. Okay. Another note you will find out here. Let's say we are having a categorical data, continuous data, right? So categorical variable and continuous variable in our model. And the slope coefficient is also you are getting. We talked about when we did the regression equation, we talked about that slope coefficient intercept term, isn't it? So how will you interpret? So this note I have included. Interpret this slope coefficient for your continuous data, for your categorical data, and for your intercept term. And this is important for your interview. So it is included in this materials. Okay, just go through, and obviously the example is also given over there. So as because we have already discussed it, so I'm not going to repeat it again. You just go through it, and if you're having any query, get back to us. We will answer you. So I'm done with the course. I mean the syllabus. I'm done with the syllabus, whatever included. And now if you're having any query, you can ask me, or you can just drop us a mail so that we can get back to you. And you will get the notes in just 2 days. Okay. And that's all. And keep on reading. And as because statistics is a vast thing, we tried to cover up the very important topics, obviously. And obviously there is a advanced level topics, just like your random forest and everything. But what I would suggest you, don't refer to any books right now if you are totally new to this statistics world. Whatever materials we are providing, that is enough for your understanding, and trust me, for your analysis and for your interview as well. And after that, when you are completely comfortable with this part, then you can go ahead with other topics. But now it is enough for your interview, for your statistical analysis, for your any modeling part. And I hope when you will start applying these concepts, when you will do R and SAS, you can relate the things accurately. Okay. So, and one more thing, please keep on practicing, because these concepts are very important. And when you are listening to me and when you are doing the class, it's becomes very easy. Okay, I can remember it. But main problem arises when you just start implementing and you just forget, that you start forgetting the null hypothesis of different tests. Mainly people get confused in that null hypothesis part, because it's difficult to remember those null hypothesis part. And unfortunately, our system is not going to tell us what is the null hypothesis, what is the alternative hypothesis. It will only give you the value. On the basis of that, you have to take that decision. So that's why you have to keep on practicing, and the notes are available, right? So just go through it whenever you get time, and whenever you are doing any kind of analysis, try to implement it, try to do something different. And before developing any model, try to understand the data structure and the industry for what you are developing a model. And that's the main thing. Okay, we all are learning, right? Because analysis is something, I mean, it can't be understood in just one day or in just few days. It takes several years to understand statistics as well. So keep on reading, keep in touch. For any query, anything, we are here to help you out. Thank you so much, guys, and thank you.
Hello everyone. You can subscribe our YouTube channel for latest updates and courses. Uh, Thank you, Mutisha.
Yeah, thank you. Bye then.